Hi, Dr. Patty. It's Matt here, explaining my work for my final exam. Um, Sorry I don't have the questions up because I already submitted my test and I'm now filming my video, so I might forget the constraints, but here we go. So for question 2, we had to see if the 1 centimeter excess worked for the two deliverables. So I first started solving for S. This is for A with a CN of 40. So I solved for S and then used that to plug in to find my TL. Found that in hours and then converted my TR to hours. And I didn't need to do a correction factor since the my I value was equal to 0. So then I found my TP, which is 5.16 hours, and then I was able to find my my flow using the TP, which I got 1.41. And then in the top right was the schematic for how to graph the hydrograph. And I just plugged everything in. I found my TB, and then I was able to find the volume and use the original area to divide those two to get a 1 centimeter excess, which worked. For B, I went through the same process and I used my new correction factor since we had the I value of 45%. But then when solving for everything, I did not get a 1 centimeter excess that worked perfectly, but I think I might have potentially messed up a calculation somewhere, but yeah, I just went through the same process for that. And then I explain the differences between the two. Question 3, I followed the same format for the one in-class problem we did. To get the rainfall excess, I took my intensity. I set it up per slot. So yeah, the one slot is half hour. The first half hour, and the intensity is 2.2, and then I did that for each set. Um, so yeah, my few factor is 1.1 inches per hour, and then to get the rainfall excess, I subtracted my intensity by my phi factor, and then with that number, I times that by the time to get the rainfall excess for each slot. And then to get the runoff, I took the sum of all those values, and then for rainfall, I took the intensity times the time for each slot, and then sum that to get my total rainfall, and then infiltration is just total rainfall minus the runoff. And then for 4, I went by the constant slope method, how we did in class for the first problem. So when the rainfall begins, you have the flow rate in the day. So that, and then I set that up same, and the inflection point, the time, and the flow rate. And then to get the slope, I did the flows over the difference in flows over the difference in time, so I got 140. And then for B, I got all the base flows, which after the rainfall begins, the base flows stay the same. So that's my chart for that. So it would be 500 meters cubed per second for day 4. And then for C, if the flow rate was 1,800 meters cubed per second, the runoff would be that subtracted by the base flow for day 4, which is 500. So I got 1,300 meters cubed per second. And then for 5, I went over the same process we did, I think, in the in-class problem we did in week 12. So you started with your time and your flow rates, and then you take, for the first half hour. The excess, you times the excess by the flow rate and then go all the way down. And then, so that's only till half hour. So the next flow rate over would start at a half hour. So the 2.5 excess would start at a half hour, and then did the same process, multiplied the excess by the flow rate, went down, and then everything went in continuous with the same process. And then total rainfall, I just summed up the excess per each step, and then I plotted all my points on that graph for each excess, total rainfall, and then the original flow rate, as you can see by the schematic on the right. So, yep, that's my work. Just wanted to say thank you again for a great semester. I learned a lot. I'm looking forward to, I think I'm taking surface hydrology spring of senior year. So hopefully if you're teaching that, I will see you then. Thanks. Have a great summer.